Good afternoon. I'm Heather. This is my coworker Shibata. We're both product engineers on the Network Analyst team, and we work primarily with the vehicle routing problem solver. We're here today to talk to you about optimizing your fleet of vehicles with that VRP solver. So we'll start by discussing what the vehicle routing problem is, and then look at the basic modeling options that we have within our solver. And then we'll look at the REST API and Python API, but we'll do most of this through demos because that's the best way to actually learn our software. So we've got 3 demos planned: multiple capacity routing, the second one's incremental assignment and multiple day routing, and the third one will be automation with APIs. So what is the vehicle routing problem? There's a lot of businesses out there that send a fleet of vehicles into the world to try and service a set of customers. And each of these companies have their own unique business constraints that need to be followed, and the customers that they're serving also have their own requirements. So the vehicle routing problem tries to account for all of these different constraints so that it can assign orders to routes and then sequence them in such a way that it minimizes that total operating costs and improves customer satisfaction. So we've got a lot of different ways to use the VRP solver across our platform. The top one, the ready-to-use VRP service, is a pretty cool option because it requires just having an ArcGIS Online account with some credits, and then you can use it throughout the platform. The bottom 3 all require having the Network Analyst extension and a local network data set. We'll do our first 2 demos today using ArcMap with the Network Analyst VRP layer. So we've been making improvements to our VRP algorithm, and we wanted to share with you some of the improvements that we've completed. So within our route solver, we've improved the quality and performance when you're resequencing those stops. So that's called the traveling salesman problem, and is essentially a single route VRP problem. Within our VRP algorithm, we've also improved a basic version and are working on expanding those capabilities. But since we've got a working portion of it done for this basic one, we wanted to be able to get that out to the users as soon as possible. So you can access that using a solver override called Optimize for Local Orders. It does require some very specific setup for that VRP layer, such as no time windows or breaks, and all of the routes have to be exactly the same. If you want full details on that, we have that included at the end of this presentation, so when you download it, you have an electronic copy of that. Or we've got papers up here and at the Network Analyst Expo. So if you think you've got a really simple, basic VRP problem and want to explore if this will help, come talk to us and we'd be happy to look at what you've got. So our VRP solver has a lot of different modeling options, and this is so we can try and reach as many of those different business constraints as possible. The top 3, orders, depots, and routes, are what's minimally required to get into the solver. Orders are where you're trying to go for the day. Depots is where you're starting and ending your day. And routes is what we use to model both the vehicle and the driver constraints. Today we'll also take a look at setting up brakes and specialties. But we do have a few other options here. If that's something that you really want to explore, you can talk to us at the expo, or we've got good documentation on those. So we'll jump right into our first demo. For this, we're going to be looking at delivering large home appliances. So there will be delivery pickups and some exchanges. They want to track both the cost for the driver and the vehicle, so we're going to model the cost per hour and the cost per mile. Because these appliances are both large and heavy, we need to make sure we don't overload the truck in both volume and weight, so we're going to model both of those within this problem. The company is very concerned about safety, so they don't want these trucks making U-turns, which is a pretty dangerous maneuver for a large vehicle. And they also don't want the driver to have to cross the street with these large appliances. And so we want them to park on the exact same side of the street as that customer. The drivers are going to have a 10-hour workday with a 1-hour lunch break. And our premium customers are going to be given time windows, either 2 or 4 hours. So I'm going to switch over to ArcMap. It's taking a second because my computer decided that PowerPoint presentation was going to mess up all of my settings. But So we're here in San Francisco for both of our demos today. And the circles here, oh, you're not even seeing that at all. We'll try unplugging and replugging. There we go. All right, we'll start that again. So we're going to be in San Francisco. The purple circles are our order locations, and the green square here is the depot. So we all set up ArcMap a little bit differently, so I want to orient you to my screen so that you know where we're looking. This is the table of contents. That's just the layers that I've got for the demos. Here's the Network Analyst window. That's where we'll be setting up everything. If you don't see that on your screen, you want to use the Network Analyst toolbar, and then this button here will toggle that on and off. And if you need a new VRP layer, that's from the drop down here. So the first thing we'll look at is the layer properties. So within here, my zooming's not going to work. Okay. Right here we've got the capacity count. We want to set that to 2. That's because we want to look at volume and weight. And then the next thing we need to set in here is the U-turn at junctions. So here we've got it set to allowed only at dead ends. And that's because we don't want them to make those U-turns, but we do understand at a dead-end street there's really no other option, and sometimes you still have to go down those roads. So those were the 2 things we wanted to point out in the layer properties. Next we'll take a look at how we've set up the orders. So the first thing of note here is the service time. And you'll see that it ranges in time from a half hour to an hour and a quarter. And that's how much time that driver is expected to stay at that particular customer location. Next to it's the time windows. So that's the appointment times that we give the customer. So here's an example of a morning time window from 8 to noon. And then some afternoon ones, 1 to 5, 1 to 3. If that value is left null, that means that that customer doesn't have a time window constraint, and so they can be visited at any point during that day. We'll scroll over a little bit. Next, we've got our delivery and pickup quantities. So this is how much is actually going to get delivered or picked up from that customer location. So for the most part, it's just the delivery quantities, since we're trying to deliver these large appliances. But within this one field, we need to model both the volume and weight. So we've got the 2 numbers in here, 160, that's our volume. And then we separate it with a space that indicates to the solver that it's ready for the second value. And then we've got the weight, 960. So it's really important that you keep track of what order you're putting those in. So volume and then weight needs to be done in that same order for all of them. And then also when you're looking at it for the routes. The solver doesn't know any difference between the 2, so it's got to be volume and then weight, or whatever sequence you have them in. So when we've got both a delivery and a pickup, that would be an example of an exchange. Or if it's just a pickup quantity, that would be an example where it's a return for this company. The next thing we'll look at is our curb approach. So for the most part, our curb approach is set to right side of vehicle, and this is to try and get that truck to park on the exact same side of the street as the customer. So this is in San Francisco, where we drive on the right side of the street. So by setting it to right side of vehicle, that means that the car has to park on the right side with the customer also on that right, and then they don't have to cross the street at all. At the bottom here, I've got a few that are marked as either side of vehicle, and that's because these are commercial locations. And they've got a parking lot that's large enough for that truck to actually turn into it and then turn around without having to back up at all. And so we mark that as either side so that that truck can come from either direction down that street and make a right or left-hand turn into that location. So that's it for the orders. Next, we'll take a look at how we set up the routes. So for the routes, we've modeled 4 of them, and we've modeled them all exactly the same. If you've got, say, 20 routes and they all have slightly different parameters, you can go ahead and send them set up the parameters all differently, and that's just as good. So for us, we've got our 4 routes, and they all start and end their day at the warehouse. So starting depot and ending depot are both set to warehouse. Next, we've got to know when that route's supposed to start. So we have marked earliest start time and latest start time both as 8 a.m. because we wanted it to start at 8 a.m. sharp. If you've got some wiggle room in there, you can put a range, and that'll allow the solver to move that route start time. Scrolling over a little bit more, we've got next the capacity. So again, we need this in the order volume and then weight. So we've got 1,000 for our volume, separated by that space, indicating that we're ready for the next value, and then 20,000 for the weight. For our cost, we've modeled the cost per unit time. That's how much the driver is getting paid, so they get paid $24 an hour. Next is the cost per unit distance, so how much it costs to operate that vehicle, and they've decided that it's 80 cents per mile. The last thing that we're modeling is our workday constraints. So for this, we've got max order count and max total time. Max order count is a required field for the VRP solver, but it's not necessarily a required business constraint. So we wanted to talk through how we came up with a value for that. So max total time is a requirement. It's a 10-hour workday. And if you remember back to our orders, the shortest service time was a half hour. So now imagine every order has that half-hour service time, and there's absolutely no driving. The most you could ever do in a 10-hour workday is 20 orders. So that's how we came up with the max order count. And it's important to have that value large enough that you're not artificially constraining your problem if it's not a workday constraint for your company. But you also don't want it so large that it's going to slow down the solver performance. So we've got our routes modeled now. The last thing we want to put into this problem is that 1-hour lunch break. So we need to model a lunch break for each of our routes, and we'll take a look at how we set up the first one. So they're going to have their lunch break start sometime between noon and 1, so we use the time window start and end time. It's a 1-hour lunch break, so service time is set to 1, and they don't get paid during this lunch break, so we set is paid to false. Once you have that for all of them, you're ready to solve this problem, so let's take a look at what that solution might be. So we've got our 4 routes now, and this is the minimum cost, but I do notice that the red route here is a lot shorter looking than the others. It could be that it's got a lot of service time, but there are times when a company would want to have balanced workloads so that all of the routes are roughly the same. So I want to take a look and see if it is indeed shorter than the other 3. So going into the route table, I'm going to look at the total time. So that's this field here. And it is indeed shorter. So that first route is 5.5 hours, whereas the third one is almost 10 hours. I can see as the route planner both drivers being upset with me. The first driver comes to me saying, I have bills to pay, why can't I work more hours? The third driver, on the other hand, is coming to me saying, did I upset you? Why do I always work so much more than everyone else? And so for reasons like that, it is sometimes better to have a little bit less optimal on the distances and the times, and a more balanced solution on routes for all of them. So to influence the solver into making a more balanced solution, we're going to use overtime. The first thing we need to know is what is an average workday supposed to be. So within total time, I'm going to look at the statistics, and it looks like our average workday is about 8.25 hours. So I'm going to round that down to 8, and we'll put that into our field calculator. So overtime start time, using the field calculator, I'm going to just type in 8. And with 4 routes, it's probably not necessary to do this with the field calculator. It's pretty quick to just type those in individually, but the more routes you have, the more important that would be. We also need to use the cost per unit overtime, and we're going to double our normal cost per time, so we're going to make that $48 an hour. Now we're set up for our second solve. And it looks a lot longer. Let's take a look and see how much we actually changed it. So again, in the route table, I'm going to scroll over to total time. And now we're looking at 7.5 hours as our shortest and 9 hours as our longest. And I think that's close enough that we can give these to our drivers. So in that demo, here we go. In that demo, we looked at a lot of the basics of how do you set up VRP. We had both pickup and deliveries. We had the volume and weight modeled within a single field. We also had a global U-turn policy that we set, but a per order curb approach. We gave our orders time windows and our drivers breaks, and then right there at the end, we looked at how we can balance those workloads. So for our second demo, we wanted to look at some of those harder constraints that we get asked about frequently. So for this, we're going to do health inspections of clinics and hospitals. And unfortunately, the two inspectors, Tom and Jerry, have gotten pretty behind on their yearly inspections, and they have been told that they absolutely must get all of those ones done this week. They do have the work that they were supposed to do, however, and they've been told that they can push that a single week if they need to. So we have this idea of a required and additional stops to take advantage of. So they've come to us asking if we can help them model the entire week at once, because there's a lot of work weekday constraints that they're concerned about, and I think that's what's caused them to get so far behind. So we'll go back to ArcMap, maybe. There we go. And we can all still see it, perfect. So I'm just gonna switch into the second demo now. Again, we're still in San Francisco. The circles are the clinics and hospitals. The green square is the starting location for this. So we looked at a lot of the basics last time. Now we're gonna just focus on those two constraints. So we have the weekday constraints that we wanna model, and then the required and additional stops. So we'll start with the day of week constraints. And we're gonna do that using specialties. So the specialties table here is where you indicate what is required by a particular order that is needed by a specific route. So that can be on the route, driver, or the vehicle. So if it's a vehicle constraint, it could be something like you need a longer ladder to get to the roof of a house, and only some of your vehicles have that longer ladder, so that house needs to be serviced by one of those vehicles with the longer ladder. It could also be on the driver's side. Say that a customer only speaks Spanish, and you need to send one of your Spanish-speaking drivers to that location. That would also be used, specialties would also be used to model that. We're gonna do it for the day of the week constraints. And so we've got 8 of them modeled. The first 5 are Monday through Friday, and this is indicating that that clinic or hospital must be inspected on that specific day of the week. The next 2 are splitting the week, Monday, Wednesday, Friday, or Tuesday, Thursday. And the last one says that they can be inspected any day but Monday. So once you have the specialties table set up, we need to put that into orders and routes. We'll take a look at the orders first. So for orders, we've got a field called specialty names. This is where you indicate what specialty is required by that order location. So for example, this hospital here says that they must be visited on Monday, and these ones here say that they can be visited on Tuesday or Thursday. Again, if it's left null, that means that they don't have a specific requirement, and they can be visited by any of the routes. So that's it for orders. Let's take a look at the routes. So for the routes, we're gonna use the name field to indicate both the driver and the day of the week. So we've got 2 inspectors, Tom and Jerry, and 5 days of the week, Monday through Friday. So we now have 10 routes within this single problem. I'm gonna freeze that field so we can put it right next to our specialties. So the specialty names field in this indicates what specialty that route is able to handle. So for example, Tom on Monday can go to any of the clinics or hospitals that has a specialty of Monday. Tom on Monday can also go to the clinics or hospitals that say that they can only be visited Monday, Wednesday, or Friday. And that's because in both of these cases, Monday's the available option for that clinic or hospital, and Tom's going to do this specific route on Monday. So that's how we set up our day of the week constraints. The other thing that we wanted was that idea of having required and additional stops. So to do that, we're going to actually have to solve this problem twice. The first time we're going to solve it, and we're only going to solve for those required clinics and hospitals. And then the second time we're going to solve it, we're going to try and add in as many additional ones as possible. So we do that using our assignment rule. So in orders, we've got this field assignment rule. And all of the required clinics and hospitals get an assignment rule of override. Override says to the solver, if at all possible, assign me to a route. All of the optional ones are given an assignment rule of exclude. Exclude says to the solver, pretend I'm not here and solve the problem without me. So essentially what that does is make the problem only those required clinics and hospitals. So let's take a look at what that solution will look like. So I noticed two things on this map that are different from our previous demo. The first is that the routes seem to go over the water. We haven't done anything cool like give them jetpacks. All I've done is set the output geometry to straight line, and it sort of cleans up the map if you don't need to know exactly what route they're taking. The other thing I notice is that there's a lot of overlap of these routes in a geographic region. This is because of all of those day of the week constraints we've put into the problem. So I've symbolized the routes by the day of the week, and you can see that their route goes into this one region on multiple days. So we now have all of our required clinics and hospitals in here. You can see that there's 25 optional ones. Those are the ones that can get pushed a week if needed. And the others are assigned to a day of the week and a driver. For our second solve, we want to try and get as many of those optional ones in there as possible. So we're going to change that assignment rule for these. So for the required ones, it's currently got an assignment rule of override. We're going to change that to preserve route. Preserve route says to the solver, I'm happy on this route, I want to stay on this route. You can add more orders to it, you can resequence the whole thing, but I'm going to stay on this route. For all of the optional ones, we take that assignment rule from exclude and change that to override. And again, override says to the solver, assign me to a route if it's possible. So we need to do that for all of them. And the best way to do that is using our field calculator. So I wrote up a quick if-then statement, and I'm pretty terrible at typing correctly while speaking, so I have that written, and I'm just going to copy and paste it quickly for you. And then we can take a look at it. Okay, so now if we look at what we've got, the one complicated thing about using the field calculator for our assignment rules is that you have to use the index for it instead of those really nice words that I've been using. We've got them documented, so it's pretty straightforward once you know that you need to use the index. But to talk through it, first we check if the current assignment rule is 3, and 3 is for override. So if it's override, that's the required clinics and hospitals. Then we change the new assignment rule to 2, and 2 is for preserve route. Next we check if the current assignment rule is override. So this is for all of the optional ones. If that's true, then we want to change the new assignment rule to 3. 0 is exclude. And if that's true, we want to change it to override. So that's the optional one that goes from exclude to override. And then I have an else statement that just changes it to exclude. That's just to help me know if I've messed something up for this demo. So we'll go ahead and look and see what we've got. So we've got preserve route now and override. I don't see any exclude, so I think we're set. And we'll solve it the second time. So this has a warning message. It says some orders could not be routed due to violated constraints. We expected that. We didn't think they'd be able to get everything done in a single week, but by routing the entire week at once, they're actually going to do really well. There's only 2 of them that are left unassigned. They can then take these and make them required for next week and continue this 2-step iterative process. So in that demo, we looked at the required and additional stops, doing the 2-step process, and then we used specialties to do multiple days. I'll now hand it over to Shubha to look at the APIs.
Once you get a hang of solving this problem for your business constraints, the next thing you would want is to automate the process of solving this. So for that thing, we have 2 APIs. The first one out of those is REST API, and the other one is the Python API. So let's look into REST API. I think most of you might already know or might have used REST API, but if you haven't, it's pretty simple to start with. There's flexibility of input and output parameters. In here, I am able to send just the JSON strings as input compared to feature classes, which we want in ArcGIS Desktop. For modes of execution, we have 2, synchronous and asynchronous execution, and in the next slide, I'll show you the difference between those. You don't need to install any additional software for this. You just have to consume the service we have online for you. Or otherwise, if you have ArcGIS Enterprise license, you just have to publish the VRP GP service, and then you'd be able to go ahead with that. So as I said, for the 2 modes of execution, for synchronous execution, you just submit a request to this URL with the JSON parameters that you have, and the server waits for the result, and you get the result at the end. Compared to this, in asynchronous execution, where you submit a job to this URL, at the end you get a job ID, and for that job ID you have to keep checking the status of that job, and once it is successful, then you get the output as the param URLs, which if you append to this URL, you'd be able to get the results. So a general rule of thumb is, if you have a request that would solve in just few seconds, you should go for a synchronous execution. If the job would take longer time, then you should go for asynchronous execution. So I'm going to show you a dev lab that we have written for starting with REST API. It's pretty simple. It's just an extension of what we just saw for delivering the appliances. Here, few customers have called us that the appliances don't work, and for that subset of customers, we want to send repair persons to those locations. So let's go to the dev lab. If you go to developers.arcgis.com/labs, you'll see all the labs here. And down here, if you click on REST API, and if you click on routing, this is the one we are interested in. So let's open that dev lab. Just adjacent to the REST API, you'd see the ArcGIS Online dev lab, and that in there we have solved the same problem with the plan routes tool that we have in ArcGIS Online. So if you're interested in that, go through that dev lab too. It's pretty simple. So here you'll see there is documentation on the Network Analyst services we have, the VRP properties and so on, if you want to know more of the constraints and how you could have that in JSON format. That's where you'd find information too. So to start with REST API, we recommend using Postman because first it's pretty simple to use and it's a free software. So running that particular request in Postman would be the best way to start with REST API. And the other thing is, if you have worked with JSON, you would know how simple it is to just forget a comma or a bracket, and how frustrating it would be to understand where you went wrong. So this is how Postman looks like. If you want to create a new request, this is where you click, and that would let you create a new request. Here you will provide the URL, Here are the parameters that you want to send, and once you have everything set up, you just click on send, and that's it. It would give you the result right there. So the first thing we want is the request URL. This is the one for asynchronous VRP service, so you'll be able to start from here with that URL. In parameters, the first one is format, that is JSON format in this case. You would need a token if you want to run the service which we have already in ArcGIS Online, and that's where your credits would be consumed from. So you would need a token to run that. So for that, there is a tutorial to get the token, and that's just a small step to get the token. Once you have that running, you can for sure automate the process of getting the token and then work with this, the automation that you're working for. At the end of the solve, we want to get the directions, so you would be able to send those to drivers. So that's why I set the populate directions parameter to be true. For U-turn policy, I don't want drivers to take U-turns from anywhere, so I set that to no U-turns. So these are the three required parameters: depots, routes, and orders. For depots, we have attributes. In this case, I've given just one attribute, the name, and we would need the name because in routes, that's what we specify as start depot and end depot name. And then it has a geometry, so XY coordinate. For routes, we have the route name, the start and end depot name, the capacities on route, max order count, and max total time. So if you observe, the parameters are the same as what you saw in ArcMap. It's just that it's a JSON string compared to what you had in ArcMap. The orders are the locations where service is to be made. So for that, we have name and service time. So it would take around 10 minutes for the repair persons to decide what to do with the appliances. And for every order, we have geometry. So these are just the basic constraint or the basic parameter or attribute information we have provided in orders. But in your business case, it could be much more than this. So just get this working and then add your constraints, and you would be ready to go from there. We also have default date in this case, and it's a little tricky than ArcMap because in here we accept the Unix time. So what is a Unix time? It is a number of milliseconds that have elapsed from 1st January 1970. And don't worry, you don't have to calculate that manually. There are online converters for this. You just have to provide the date time, and then you would get the Unix time. So once you have got all this information, just click on send to run the request, and at the end you would get a job ID. With that job ID, you just keep checking the status of your request. Once it is succeeded, that's when you would see a result something like this. So in here, in results, you would see that there are param URLs. So these are the URLs that you would need to see that particular output. For example, for output routes, you would have the basic URL till job ID, and then you just append that param URL and you would get the output routes. For output routes, you would see there is geometry, there are fields, and there are the route features that you would get with the routes. Similarly, you would be able to see the stops, output stops with a similar param URL, and that's again in JSON format, wherein you would see the route name for that route, for that order, the sequence in which the route or the order is served, the arrive time at that order, and the depart time. Similarly, you would be able to see the directions. So once you have the directions for every route, then it would be easy for you to share those directions with drivers, and they would be ready to go for the day. Then if, for example, if you have time windows for your orders, then how would you add that to orders? It's pretty simple to add just an attribute for time window start and time window end. Just remember that all the time window fields that we have for VRP in REST API, you have to provide as Unix time, similar to what we did with default date. So it would look something like this. For this order, we added time window start and time window end, and that should be the Unix time. So this is it. It's a simple problem that we have solved, and there is already a dev lab that is online. So I hope this helps you to start working with REST API, and once you have got that working, it's pretty simple to embed that in a Python script and then make an automation out of it and run it a number of times. The next one, the next API that I wanted to talk about is the Python API. And it's pretty new in terms of how it is being used. It's being used in data science and machine learning fields, and people are loving it. And the good thing is we have the VRP API in this Python API too, so you would be able to take advantage of that. If you go to developers.arcgis.com/Python, that's where you'd find all the information of how to install this API, all the guides and the API reference and everything. We are going to have a look at a sample notebook that we have written for VRP, and you'd find that under sample notebooks in GIS Analyst and Data Scientist, and that's where you'd find the finding routes for appliance delivery notebook. So this is a simple notebook wherein you have the line by line execution capability. You just write a line and then the history is saved for you. You don't have to run the whole script and make changes and hold the script again. So the first thing we do is we get the libraries. Then we connect to the portal, ArcGIS Online portal. If you have ArcGIS Enterprise, then it depends on what security you have set there. If you don't have ArcGIS Online account, there is a link for you to try ArcGIS Online. So let's see if we have orders in terms of a CSV file. Then you would be able to just read the file in data frame, and there's an API to convert that to feature data set, and then you would be able to just give that feature set to VRP, and it would be it. So this is the order CSV, and in here we have just the addresses, and it created the feature set for us. Then if you have a routes information in a CSV file, you have all this information of capacities, max order count, and everything. In that case also, you would be able to just read that CSV and convert that to a feature set for you to use. So this is how the routes feature set would look like. It has the information of start, depot name, the earliest start time, capacities, and cost per unit time. And here you'll see there is some code to convert the date time of the route, which we get from CSV, into the Unix time, which is also accepted by the Python API. Then if you have a depots layer and depot CSV file, and for that we have longitude and latitude information, then you would be able to just read that CSV to create a feature set out of it to send to VRP API. Once you have got depots and orders, let's see how you could visualize that in a map. Again, with few lines of code, you would be able to see that in the map. So WebGIS is a pretty cool thing wherein in just few lines of code you would be able to run the solve and then visualize it in the map, and it's pretty interactive. What if you have depots just as an address? Because it can happen sometimes that you have just one depot for your organization, and that's where all the routes start. So you don't have to create a CSV to do all these things, right? So in that case, you would be able to just geocode the address and convert that to a feature set, and that you would be able to use to send that to VRP API. What if you have got a JSON file from a REST end? So that's simple too. You just read the JSON file and then convert that to a feature set, and that should be it. So we just saw how there are different types of inputs. You could have a CSV with address, CSV with latitude, longitude information, or just an address, or you could have a JSON string, a JSON file. It's pretty easy to convert all that to a feature set and then use it for sending further to the VRP API. That's the strength of the Python notebook. Once you have got all that information, we solve VRP with all those input parameters. Here you'll observe I'm setting the save route data parameter to be true, and that's because at the end I want to save the route data that comes as a zip, and once I have the zip, I upload that zip to ArcGIS Online, and there is a functionality wherein you would be able to get the route layers out of it. So the solve is succeeded. In the results, you would be able to see that these are the output routes. Here you'll see how many orders are on those routes. When do the routes start? When do the routes end? What is the total cost? What is the total time? And so on. Similarly, if you observe the output stops, you'll see the route 1 starts at warehouse, and then number 5, number 6, 9, and 7, these orders or these stops are served, and then the route 1 ends at warehouse. And it also shows you the arrive time and depart time of the route at that location. If you want to visualize the route in map, it's again possible with few lines of code. The orange route is route 1 and the blue route is route 2 in this case. And you can always play with symbology of how you want the routes to look like, what is the thickness of the line, and so on. As I said, once you get the route data in zip, I just uploaded that route to ArcGIS Online. And with that zip, I am then able to convert that to route layers with just an API, create route layers. And these are the routes that we have in online. So once you have the routes in online, it's pretty easy to share the routes with the drivers, and they would be able to open the routes in the Navigator app that they would have in their phone. And recently in Navigator app, we have this functionality added that you would be able to search the route by the name of it. That's in beta 4, but you can always take advantage of the beta version, and if it helps you. So in this demo, we saw how you could use REST API and Python API for ArcGIS, for VRP. We saw how you can plan through ArcGIS Enterprise. At the end, you have the full logistics plan, and the Navigator, with the Navigator app, the drivers are ready to go for their day. The numbers speak success, and this is just one customer that we have, Pima County. They used our tool for building inspector routing plan. They saved $33,000 per vehicle. They reduced mileage by 34%, and they're saving $197,000 per year on mileage and inspector's time. So that's huge numbers. I hope this inspires you to try this tool, and I hope this helps you solve your problems. These are some resources we have listed here. And there is a community, GeoNet community for Network Analyst, wherein you could post questions, and we'd be happy to help you there. Please share your feedback. That would really help us for next year. There are pretty interesting tech workshops and demo theaters by the Network Analyst team. Do go to those. Our colleagues would be happy to see you there. And all this material about data and the demo data and everything is saved at this link. So if you want to download it, it would be available for you to download here. And now we are open for questions. Thank you.
Yeah. Right.
Feature, which is kind of a positive relationship to No Monday. Is there anything there the pipeline to create something to, have like, negative specialty, so like a negative association to a specialty without explicitly having to write it that way? Because I imagine every route that works a day besides Monday, that needs to be attached to them, right? And then, so if you have a system where instead of just 7 categories for days of the week, you have much more, it could get kind of overwhelming to organize it that way.
Yeah, so the question is on the specialties and how we modeled one as no Monday. Is there a better way to do that without having it say anything but Monday, I guess is what you're going for?
Right, like negative Monday or something.
Yeah. So we have had some customers that list out every possible permutation of those 7 days of the week, and our solver can handle that. So it's okay if there's a lot of different options. Another way to have said no Monday is they're available Tuesday through Friday. And so there are a lot of options, and you're just going to have to list out what works for your company. Yeah.
I'm just curious why you guys used ArcMap instead of Pro. Is VRP Solver hasn't been introduced to Pro yet? Or?
So the VRP solver is in Pro, but it's only using the GP tool currently. We're working on getting the nice ribbon UI that matches our other solvers, but we just haven't done that yet. We've got a few other things that we're working on. Yeah.
Is there a way to submit to the VRP with different travel modes for each route?
So the question is, can we put different travel modes on each route?
For example, could I have 4 routes and each have a different height restriction?
I don't think so. Yeah.
Are there any plans to update the VRP to accommodate that?
Not currently, but there are ways in the GeoNet to have suggestions, and we'll obviously take that back too. But if a lot of people are on there saying, hey, we want multiple different vehicle constraints, that would influence our bosses to let us do that kind of work more. Yep. Yeah.
So if the travel mode is not supported, then how we can specify whether it's a box, like it's a truck or a car?
So, yeah, so the travel modes are supported. His question was specifically on, can you have multiple travel modes within the same problem? And so it would be like having a really tall truck and a normal truck all within the same problem. Yeah. So we do have the concept of travel modes in VRP. Yeah.
And also, do you have like the maximum drive speed time? So like in our organization, we literally allow like 65 miles per hour for all the VRP supports that?
Yeah, so our travel modes in general will support being able to cap the speed at, say, 65 like you're asking for. But it's a evaluator on the network data set.
Yeah, it's basically on lower speed.
Yep.
It's calculated based on but we need specific on some caps, like vehicle should not go above 65 miles per hour.
Right. Yeah. We do have that capability in Network Analyst, speed governing. Yeah. The folks at the Network Analyst Island that aren't us will know how to do that better. But I do know we have that capability. Yeah. Other questions? Yeah.
So for my particular, we pay the drivers different than some of them are on a salary and some of them are per order that they do.
Mm-hmm.
And as far as I know, there's not the current function to model it exactly how we would like it tailored. Or is that a comment, or have you heard that from other users as well? Like the flexibility of the cost function, and especially when you have to maybe manipulate something like the overtime parameters to something when it's not truly overtime, it affects the cost function. When maybe you want it tailored to how your fleet is paid and how your expenses are.
Right. So the question is on having different pay structures, so some being more salaried and others getting paid per the amount of work that they do. How can you put that into the solver? We've gotten that just recently, but it's a new requirement we're starting to hear. They were actually wanting to have the ones that were getting paid per order do all of the ones that were really far away. And so you can work on that by first solving the problem with all of your salaried ones, and that'll naturally get into the closer in ones, and then solve what's left over for the per order ones. But we don't currently have a way, like you're saying, to have that specific cost structure. Other questions? Yeah.
When you use it with Esri Online, how much credit is the
It's per 1 credit per route.
1 credit per route, even if it's a complex route?
Yeah, 1 credit per route. Yes.
Other questions? No? Well, thank you so much for your time.